Hello, everybody. This is going to be a quick video on how to do the phaser warm-up for the Iterative Averaging Studio. And in this video, we're going to basically build a program, a parallel program in two different ways. They're both going to be, I hasten to say, identical, but they will appear to be identical, that one will have less overhead than the other. So in our main, we have a list of letters and a list of digits, and then we're going to basically print out the pair of the number and the letter. And we don't know where the letters will all be done in parallel, so we won't know what order they come out in, but we'll know that the 1A's, 1B, 1C, 1D, we don't know what order those will go in, but they'll all happen before the 2A, 2B, C, 2D. So let's just dig in and start to build this. So this is not the most contrived of programs. It's a fairly reasonable thing to have like a number of iterations, each of which does a parallel program. So in this, we're gonna have a sequential loop on the outside for each of the digits. We're gonna do that, and then we're gonna have a parallel loop on the inside. So for all letters, let's have it pass us that letter, and we're simply going to sys out the pair that is digit plus space plus letter. Okay, and so when I run this program now, we'll see down here, it prints out A, B, C, D, E the first time, A, D, B, C, A, D, B, C again. All the ones have happened before all the twos. It can run different. Now we haven't built the phaser one, so that's the exception, right? But you can see it's not necessarily, we're not controlling the order in which these print out. And here, because that's in parallel, that makes some sense, right? So it can be different every time, but we want to have this constraint where all the ones will happen before all the twos and everything like that. And that makes sense. We have a sequential program that sits there and runs for all. For all, of course, spawns a task for each one of these things and then has a finish, so it completes before the next iteration. Now, the phaser program we're going to build will have the same output, if you will, but with less overhead. Okay, and if you think about it, for each one of these digits, we create a bunch of tasks, spawn them, and then join them all together and destroy them, and then create the same set of tasks, and then spawn them, run the work, join them all, destroy them. So what phasers allow you to do is flip it inside out. So the first thing I'm going to do is just that, right? So that seems crazy that we're going to somehow be able to flip the loops inside out, one of which was parallel and still produce the same program. What we're going to need to do is do that join all part that happened every time. And so in this case, what I'm going to do, how I'm going to pull that off is I'm going to make a phaser. And a phaser is something that was in X10. They've actually added it to Java since. I think if you tunnel into this, it actually will reference up here in its docs. Let me see if I can find out X10 in here. Yeah, this is very similar to X10, thanks to Professor Sarkar and Saraswat for this work. And so this is a nice thing when like a research system like X10, some of the features that they have start to make their way into languages like Java. So we're going to need to create that phaser. You can actually pass how many parties you have to a phaser right there, but I'm going to call bulk register explicitly. The idea here is that you're trying to say, well, how many different tasks are going to arrive before you move on to the next phase. And so in this case, this is going to be the number of letters that we have, because that's how many tasks we're going to make. You can see it right here. And basically, all of those tasks are going to complete before we move on to the next iteration. Okay? And so what we have to do now is say phaser dot arrive and await advance. And if I run this program, they both have the same behavior, right? Again, we don't know what order the twos will come in. excuse me, we don't know what order the ones will come in. We don't know whether the twos will come in. We don't know the orders of the threes, but we know that all the twos will happen before all, all the ones will happen before any of the twos start, right? All the twos will happen before any of the threes start. And so this is a way in which you can build the same program, if you will, just with less overhead, better performance. And that's what phasers exist for. And they were useful enough in X10 that Java added them directly. So good luck using this in your studio, and have fun.